So hello and welcome to the session. My name is Sanjay Goil. I am part of the product management team in the database cloud at Oracle. With me, I have Paul Parkinson, who is in the microservices team. So I'll let Paul introduce himself and then we'll get started.
Yeah, I've been at Oracle for almost 20 years now, 19 years, and I've basically had the same role of working in the mid-tier in transaction processing. And so although I'm in the mid-tier, working closely with the database tiers, and Sanjay and I have been working closely on different projects in that area related to microservices.
Great. We're going to talk about using Helidon and GraalVM with the Converge database, but mainly focus on building microservices with the database. A lot of times, microservices are built with the application layer in mind. And what we're going to present is, thinking about both the application and the data tier. There's also a messaging tier that comes into play when we're looking at microservices. So let's dive into it. It's about 100 minutes, I think, this session where we kind of have a lab walkthrough towards the end. But mainly wanted to cover, what is a microservices architecture, what is data-driven about it. Then look at the application. So we kind of took a mobile food ordering. So if you are familiar with your own local mobile food delivery application, we can think about an order coming in, and then that event starts to look for execution, right? It basically says, an order came in, you look at the inventory, then you start to look at the delivery service, you'll start looking at the supplier service. So all these things kind of work together in kind of building microservices. So we kind of talk about that. And then, we'll talk about some of the frameworks in microservices, and then mainly kind of spend a lot of time in the labs. So please feel free to ask questions. There's a Q&A panel there. So, whenever you have a question, please feel free to ask a question there. Paul and myself will be monitoring and answering those things. So by the end of this session, hopefully you learn how to build a microservices-based application with the database in mind. And we talk about the Converge database mainly because convergence means that many data types, right? So documents, which are JSON, the relational data, the spatial data, the graph data, all kind of come together in terms of having a singular data store for these things. So we have done some of this over the last 6-8 months. So Paul and I have been working fairly closely. I've been at Oracle about, this is my third year, and my background has been in big data, machine learning, and other areas, also building systems. But in terms of applying those principles to building applications, what became very clear is developers want to build data-driven applications as microservices. And we hear a lot of people come back and say, they're becoming quite complex and need to be simplified in the coding of it, in the DevOps of it, in performance, availability, security. You get the right idea, but it needs the data layer to be solved in some sense. So there is a bit.ly link here. It's called Database House Party. So even beyond this session, this is on YouTube. There's a lot of recordings of sessions that walk through building microservices, walk through some of the SQL in the database, walk through some of the spatial data in the database and all that. So again, we'll post this on chat later on. But you can also join the Slack channel. There's something called databasehome.slack.com, and join the microservices channel there. For asking questions, you can reach Paul and me at any time. So again, I think the drive is towards simplicity. The whole area of microservices has become quite complex, and we'll see why it has become complex because of the various flows in the data and other things, right? So let's kind of look at where the simplicity comes in, right? Simplicity at the app tier, the data tier, and the integration and ops tier, right? So we have to think about microservices being built at the three layers, and you'll see them as we walk you through the workshop towards the end. So what are microservices, right? I think you may have the first question is, okay, I'm in this session, I have some idea of what microservices are, but this is some of the simplest definition I found. It's loosely coupled service-oriented architecture with bounded context, right? So we've been doing service-oriented architectures for the last 10, 20 years, but loose coupling, I think, is the important aspect here. And this is why you have services that are isolated. So a good check of loose coupling is when every service has to be updated at the same time. You can basically say it's not loosely coupled, right? The idea was you can now update. You can do CI/CD on one microservice. You don't have to go look at all your other services in some ways. And the second is the bounded context aspect, right? So the bounded context aspect comes both from your workflow, right? So if you want to do orders, or you want to do inventory, or you want to do customers, or you want to do your suppliers, you're bounding the context there, right? And then you're saying if you know too much about the surrounding services, you don't have a bounded context. And I think the challenge in microservices comes from these two aspects of loose coupling and bounded context. And you will see some of the areas that we have to handle to solve these two things. So let's look at where some of the complexity is coming from here, right? And in this, you can see on the left side, there are producers of data. In the middle, you see transformation or storage of data. And on the right side, you see consumers of data. And what typically happens is a web service or an order service, APIs, mobile, IoT, transactions, you produce data. They either use a database, it could be an Oracle database, could be NoSQL, MySQL, anything else. So this data, operational data, gets produced and then kind of flows through a Kafka into multiple other platforms, right? And from there, it then gets consumed either in a mobile app, in a search portal through Elasticsearch or somewhere else. And then a lot of real-time analytics happens on this. And of course, a data lake gets created and all that. So you can see many technologies, multiple data stores. There's this thing called copy contagion, right? You kind of start to copy data many times. And again, your DBAs, your data architects start to scratch their heads around, how do I secure all these copies of data? And you can imagine it becomes complex and difficult to maintain, to scale. And more importantly, the skill set gets fragmented, right? So we started to look at this, and people started to say Lambda and Kappa architectures. And in some scenarios, this makes sense, but there are other scenarios in which you can do better. You can kind of do simpler things, where you don't have to stream everything. You don't have to use special purpose databases and other things. So we believe, using the Converge database, that Oracle has built, and we kind of walk you through some of these areas of why the Converge database and the container database, the containerization, and then having pluggable databases allows you to go through this, flow much more easily. It's got open interfaces. You can program in Java, Python, you use JDBC to get to the database. And then, of course, microservices frameworks like Helidon, Micronaut, Spring, can be used here. So again, easy app building blocks and APIs that are open, but also have a data tier that is simpler and also scalable, right? So there's less to manage and learn, and people are familiar with some of these underlying technologies as such, building these areas. So you can see that there's a lot of this modern technology that, Docker containers, Kubernetes, with service mesh like Istio, using GraalVM, and tracing tools and other things. All these tools, and with Helidon, come into play with the data platform, right? So there's a lot of work that has happened in the data platform that gives you the convergence. So, JSON has become a first-class object in the Oracle database. So documents can be ingested, queried, indexed, and everything else there. Spatial data, graph data, events, right? There's advanced queuing in the database that allows you to bring in events. And there's some machine learning and scaling, in-memory analytics, and all that. So there's a lot of fundamental database techniques that make converged database more important for microservices. And then the transactions, right? So there's, of course, XA transactions, but we're also adding sagas. Sagas are basically distributed transactions, but they are more asynchronous, and they can also support, or they're fundamentally eventually consistent. The idea there is a lot of transactions become local, and there is, and then maybe we'll talk about it a little bit towards the end. And then message API is a standard using JMS or Kafka in this area. So if you look at a stack that comes together, so either you're in a public cloud or a private cloud, you have, of course, cloud services, right? So there's the Linux cloud native environment that is on premises or on a private cloud. The public cloud, Oracle has the Oracle Cloud Infrastructure, which again, has many regions, almost about 25 to 30 regions coming. 25 regions already there, more coming. So anywhere you are, you can access a cloud region, which makes it easier to access services. There's a Kubernetes service, there's containers, VMs available, and when you start looking at the autonomous database, right? So there's also a database service, that is a managed service. Of course, you can get your own services as well. And traditional applications run with Java, WebLogic, the Java microservices with Helidon and GraalVM, polyglot microservices, again, Python, Node, Graal, and function serverless. So API gateways that allow you to do serverless. You don't really, in some situations, need the persistence layer in some ways. So if you want short-lived functions to be done, so this is like Lambda functions on AWS. There's, of course, a lot of observability and tracing that is available out there: Prometheus, Grafana, Yali, Jaeger. So all kind of bringing these things together in terms of thinking about your app tier and your data tier. And of course, some of this probably is very familiar to you if you're already down the microservices path. So what becomes challenging is how developers, like some of you are probably developers, some of you are architects, some of you are DBAs. If we had a poll, I would have asked, what is the ratio of you in each of them. But in this case, when you look at microservices, the three types of roles interact with each other, right? So you're looking at a developer, either developing an existing application where you already have a data model, and you're trying to figure out, where are my bounded contexts, where are the relationships that make all these, services become dependent on each other, which is traditionally referred to as a monolith. Right? And we're trying to break those into smaller microservices so you can have continuous integration, continuous deployment, can evolve the application in a much faster mechanism. But if you're starting afresh, you're starting to look for where is my business workflow, right? So if you're doing supply chain or you're trying to do some mobile app or IoT app, starting to look at, where is my data flowing? Where is my logic flowing first, right? So the business workflow kind of becomes important. And there are tools like Camunda and others that allow you to then code to that business workflow. And maybe bringing in a microservices framework allows you to then do annotations. So again, I think the developer looks at these three areas, and then suddenly the architect starts to come in and say, where are my containers? Where are my, where's Kubernetes? Where is this sidecar in a service mesh that allows me to look at policies, security on not only the public cloud, but also the private cloud? Because again, there is the whole, either you're, doing hybrid cloud, you're doing multi-cloud. So the service mesh becomes important. And below the service mesh, again, you're also accessing data. And that data mesh is basically, in this case, the converged database, which, when you see the illustration, you see, the gray and the red, there's basically a container. And then within a container, you can have multiple these databases called pluggable databases. And here you can start to see a lot of the data persistence aspects of microservices being used. So again, we talked about the definition, right? So there's bounded context aspect of microservices. So we design microservices with bounded context. There isn't a simple tool for that. Again, we've taken a lot of feedback. Everybody says, oh, I would love to have a tool like that. We're trying to build something in that area. It'll probably take some time, mainly by looking at access patterns to the underlying data structures, tables, and documents, and then come back with potential relationships, and then from there do some clustering to figure out that these tables are working together, these are not working together, there's potential boundaries. That there's some optimization problems to be solved there. And then of course, today people look at the ER diagrams, they look at their workflows. So in this case, you see a sales context. You have customers, products, but the sales is organized by territory in this case, and the product, the support is organized by the ticket. Right, so you can start to see where the bounded context can be, and when the relationships between the two, then you start maybe either using REST calls to connect microservices, and we'll talk about some of those things in the next few slides. So in some ways, there are certain business processes to be implemented. So that allows you to do better bounded context. Logical boundaries can be non-ambiguous in that area. You can split the monolithic database. You can also isolate application modules within bounded contexts. So again, I hope you get the idea of this. This is fundamental, but again, I don't think it's a solved problem today, and a lot of people need help in this area. So the consolidation you get with this converged database that we're talking about is the idea that you don't need to rely on special purpose databases. Today, you'll have to use Mongo for documents, or a cache for performance, or something else for analytics. So again, by bringing in these various data types, the converged data types you see on the left side, and allowing containerization, the databases become fairly advanced for becoming that data layer for microservices. And then the best aspect of it is this unified data model also gets convergence of queries, right? So if you're writing queries in SQL, or you're writing a Java, Python, Node.js problem, the polyglot aspect comes together, where you can run queries in a familiar model across all data stores, right? So that holistic view of operational data makes things very simple. So let me quickly talk about how do the loose coupling then has to do with communication. This is also available in the data layer, and then I'll hand off to Paul. Paul will cover some of the other aspects that are important in the stack. So communication can be of two types: synchronous or asynchronous. Right? Synchronous, basically one service usually kind of gives you a REST API, and you can call one service with its exposed APIs, or using gRPC calls. And you can imagine it works simply in a simple manner for a few services. It becomes a little hairy when you have large number of services. Asynchronous communication is more suited for microservices because of the loose coupling, the immutability that comes from the fact that you don't have to rely on messages that are lost, right? So again, some transactional messaging aspects come into play there. So events and messages with PubSub and notification become the fundamental asynchronous mechanism. There's also event sourcing available. So again, if you're using events and messages, you can also play everything, every aspect of your microservice as an event in an event, so in an event bus or an event store, and use event sourcing for that, right? So again, that is an extreme example, but perhaps just using messages and a PubSub bus, like either the AQ that's built in or using Kafka, you could do communication across microservices. Event sourcing, again, very briefly, is, we just talked about it. So if you have an order service can persist a change in the database, but also publish and persist an event in an event broker. And once an order is received, it then publishes the event. The inventory service then picks up that event because it's subscribed to that event broker, and can check if I have inventory and then notify the order service back, right, by publishing another event. The order service picks that event because order service is also subscribed to the event store. So you can see how the event broker, event store can become the communication mechanism between microservices, right? So again, having a good messaging layer is important for microservices. The Oracle database has transactional messaging built in. So there is something called AQ, which is advanced queuing. It's also parallelized with multiple topics being available. Like if you think about Kafka has topics and partitions. Here we call them queue tables, and then queue tables within it have shards. So very similar concepts. But here you basically can do data manipulation, right? You can write an order into a database and you can send an order message, and you follow transactional semantics. So, once this order is received in the order database, the message propagation, which is also built in, propagates it into the second database, right? So here, this receives the order, checks inventory, sends response, and this is where immutability comes in. You don't have to code your application in different ways to look at the duplicate messages and others. It's exactly once messaging, and traditionally been used for creating chained event workflows. So again, there's a lot of smarts built into the message layer that allows you to take advantage and make your microservices loose coupling more simpler. So let me hand this to Paul to kind of cover a few more aspects of the stack. So Paul.
Okay, thank you.
Sorry.
Okay.
You want to share now, or how do you want to do it?
Yeah, actually, maybe you may as well just drive, if you don't mind. I'll just tell you.
Okay, sure.
Yeah, so in the next, thank you, Sanjay. In the next couple slides, I'm going to talk about some microservice technologies that aren't specific to data-driven apps, but are all the more important for apps that deal with data. And so the first one I'm going to talk about is a technology called a service mesh, which has become very popular in the last few years. Products such as Linkerd, well, I think it was the first one, and Istio, which has become very, very popular. And Really what a service mesh is if you're familiar with interceptors, it's basically an interceptor framework if you think of how it works. So you have all of your microservices that you're communicating with each other, as you see on the right-hand side. And what these service mesh products do is they insert a sidecar, the SC blocks next to the microservices on the right there, in front of a microservice. And so this can intercept all the incoming and outgoing traffic. And in doing so, logic can reside there instead of in your microservice. And so all various different, cross-cutting concerns for microservices, such as tracing, blue-green deployments, different types of routing. This is where it is very strong as far as being able to rid your microservice code, as I say, of these cross-cutting concerns. You can move all of your security, like mutual TLS and things like that, into these sidecars. And so it's great, again, for deployment, like blue-green deployments. You can mirror traffic. So it's great for, crash testing and for mirroring traffic. So you can have the same traffic that goes to your production site, go to your QA site, for example. And so the service mesh technology is worth mentioning as a great technology used in microservices. We can go to the next slide. Now, these different technologies here are related to observability and distributed tracing. So I'll actually start at the bottom right there. So Grafana is a tool for showing time series data from different data sources, and Prometheus is probably the most famous or commonly used data source. And so your microservices are putting out this Prometheus data, and a tool like Grafana is showing this monitoring for this time series data. Another technology we see here is tracing. And perhaps the most adopted or the widely used standard in microservices, or one of them, is this open tracing standard. And so any product that is running in the cloud these days will support open tracing, and will advertise information so that you can trace the call graph of microservices and drill down on the information in tools such as Jaeger. So Jaeger will read the open tracing files. No problem. And that's one of those animation slides that slips in. Will read the open tracing information, and it says open telemetry here. That's kind of the next, that will encompass open tracing in the future, open telemetry. So we're talking about the same thing. Tools like Jaeger will read in this open tracing. Then you could do this nice drill down of this various information. And I won't go into open tracing too much, but there are different types of constructs or data in tracing. So you have baggage, which is information that is passed along the call graph, so each of your microservices can look at it. Things like transaction IDs and things like that you want to trace. And then there are other data such as tags and logs, and they're just put into the store asynchronously. This is all asynchronous, so there's no performance impact with open tracing. And then there are different visualization tools for that. So the Kiali tool here actually works with Service Mesh, works with Istio, and you have this nice visual that you see there. And so that's giving you a visual of the call graph and your workloads for different requests across your microservices. So you could see if you were debugging a problem, a hypothetical flow, you're looking in Grafana, you see some kind of errors or slowdown. You go to your Kiali to see where in your call graph the workflow is, having issues. And then you can literally click through that to drill down into the Jaeger UI and see exactly what was going on. This method took too long because of this, etc. So very powerful tools, and tools that you really are going to need now that you have your microservices, spread across these different processes. So that's why I wanted to mention this. We can go to the next slide, please. So this workshop that we have put together, which is constantly evolving, as Sanjay said, we call it GrubDash. It's sort of a DoorDash type application. And we try to show off all of these microservice architecture principles and technologies. And there are actually, we've been writing technical papers that accompany us, that accompany this application as well. But we show off concepts such as, a service in a container managed by Oracle Kubernetes cluster. The idea of data isolation that Sanjay was talking about. So in this case, we have an Oracle PDB per service. And so again, as Sanjay was saying, you could break up these bounded contexts along a number of lines, but the PDB is the perfect match for microservices because you get all of the advantages of the converged database, but yet you have an isolated PDB for scaling and things like that. So it's a really great match. So the GrubDash workshop and application shows that. It shows the event broker technology as far as the event sourcing and transactional queues. And then it shows the different Helidon microservices, and I'll get to them in a bit, microservice conveniences and features in this space. And then it shows all the different data types that we've been talking about. So for example, you insert an order in the database in JSON, but you manipulate the inventory using traditional SQL. And then your queries are based on messages, event sourcing, and things like that. So it shows all these different concepts. And again, you'll see that in the lab walkthrough. We can go to the next slide, please. And so here's where we are with the GrubDash app now. We started with this core because we wanted to show off these microservice data patterns. And so that's what you see with this basic order inventory service at the middle. But we continue to add on and on. This is, a very concerted effort in Oracle to add in these AI technologies, which is what we're working on now with the AI teams, and just various different technologies. We keep adding to this. I'm adding in OCI Vault in order to store your credentials to access the database from your microservices. And so we're also interested in any feedback that you have, anything you'd like to see in it. And indeed, in the past, we've taken feedback from customers and implemented that feature to show them in this GrubDash app. So it's good. It's an app and a workshop that takes you beyond the hello world. There's a lot of hello world demos out there. This gives you a much more robust, complete solution. And I'll go into some of the layers in the next slide, please. So this is how the lab builds you up. And so in the first lab, in the workshop, you're basically setting up, all of your Kubernetes cluster, your OCI registry for keeping your Docker images, your multi-tenant database, and things like that. In the second lab, you're doing a basic, you're setting up your dev environment. So you're just getting your source from GitHub. You're building a microservice. It's just a basic static microservice. And then, testing it. So now you have a microservice running. The third lab is kind of connecting everything together. You're setting up the database and your transactional queues, and you're connecting from that microservice in the mid-tier to the database. So by the time you're done lab 3, within an hour or so, you have this complete infrastructure for microservice development, and you're connecting from microservices to data and things like that. Lab 4 is probably the most substantial lab because now you're getting into all of the concepts that we've discussed in this presentation. All of the, the data patterns, sagas, event sourcing, eventing, and also you're getting into tracing, metrics, health, things like that. And we'll be seeing more of that in just a bit. Lab 5 is the polyglot theme. So the exact same thing as Lab 4, except you're swapping out implementations which were all in Java. You're swapping them out for a Python or Node.js or Helidon SE, different flavors of Java, microservices, or different languages. And then in Lab 6, we have a nice scaling both on the app side, where you get the horizontal scaling in Kubernetes, and then scaling on the database PDB side as well. So that's a nice, very, very simple lab actually, but shows off the scaling on these different tiers. And then from there, we just keep adding on. So you have the Apex app to bring in your front end aspects, and all these other spatial routing and things like that we're adding in the next month or two. So it's a nice, very nice workshop that we've been presenting to a number of audiences. Next slide, please. So very quickly, I'm just going to go over the microservices landscape in case you're not familiar. So what we have here is a scale of from large to small, from top to bottom. And so if you were going to go even off the scale, you would be mainframes down to, application servers, down to what we see here, which is like Spring Boot. You're starting to enter the microservice landscape, but Spring Boot is still a very gigantic footprint. So then you're starting to move smaller and smaller. The next area is micro-profile based. And if you're not familiar with micro-profile, if you are familiar with Java EE, micro-profile is a set of standards under the Eclipse org for developing apps the same way Java EE was, but micro-profile is geared towards microservices. And so you have a number of products in that area, and then even smaller frameworks, micro frameworks for running, even serverless and things like that, but extremely fast startup time, etc. Next slide. So very quickly, there are two, the Oracle's Helidon microservices platform has two versions, SE and MP. And really just very quickly, it's the difference is primarily in the development style. So in Helidon SE, again, this is more of a micro framework. So you might be working in a functional style, more reactive programming, things like that. Helidon MP, on the other hand, has full CDI support and things like this. So if you're coming from the Java EE world, it's going to be very easy to migrate. All of the annotations and everything that you're looking for are there. And I'm going to show some examples in the next slide. And then, of course, just real quickly, Sanjay and I are working together every day to do these features as far as Helidon and the Oracle database to maximize all the DB and messaging aspects. GraalVM is supported. And one of the big projects I'm developing right now is LRA support. So that's support for sagas that Sanjay was mentioning, which is the transaction protocol that's more widely used in microservices. Okay, we can do the next slide, please. So here are some annotations, and these are annotations that relate to the technologies I've been talking about in the last few slides. So, you have your standard REST annotations there. But if we look at things like traced, so in your Helidon microservice, if you simply place this traced annotation on a class or a method, that is going to trace that method and send the open tracing information to your Zipkin or Jaeger, whatever, store automatically. And so you can see that's very powerful. You did not need to even, you can code to do even finer and more specific things. But you can see by just placing an annotation, you have that tracing of your microservice. Very easy. Likewise, for timed and counted, these are metrics annotations. So, and there are a number of these. And so just by placing this annotation on your method, these Prometheus by default is the format. These Prometheus metrics will be recorded, and you can view them in Jaeger and things like that. Others include liveness. So you put this on your microservice, your Helidon microservice, and it will advertise if the microservice is alive and also if it's ready to take requests. And this works in concert with Kubernetes health probes. So the health probes will come by, they'll check the liveness and readiness of your microservice as advertised, and then it'll restart it if necessary, things like that. Incoming and outgoing are messaging support. So I don't have an example here, but that's very simple. You put it on your method, and then that will receive messages based on a channel you've designed. A channel may be a queue, and so you have ingoing and outgoing for that. Makes things very simple. And then the LRA functionality. So that's long running actions, and that's giving you Saga functionality similar to, if you're familiar with Java EE and JTA transactions and the @ transaction annotation. This is similar, is the same thing essentially, but for sagas. And so you're not using XA protocols, you're using local transactions and things like that. And so that's an area where it's, the simplicity is very important, because sagas and compensating actions can get complicated. And so it's very powerful to have an annotation like this to make things simpler. Next slide. And so actually, I will go ahead and hand it back to you, Sanjay, if you want to do a summary.
Yeah, thanks, Paul. So I think, simple yet powerful. So a lot of building blocks that we are illustrating in this GraalVM application. Again, I think our focus is simplicity for microservices, right? Again, as we looked at developers, DevOps, architects, you can see the complexity in any data-driven application. Again, kind of, at Oracle, we think about data first. And again, also modernizing applications that folks are writing across the spectrum. So loosely coupled service-oriented architecture with bounded context, right? I mean, let's not forget this definition and the simplicity of the definition of microservices. So loose coupling, finding bounded context allows you to do loose coupling. And then when you have loosely coupled, then you think about communication between these microservices, but also things like sagas that make it easier for having coordination between microservices. Again, asynchronous is the key for scalability. The Converge database as a persistence layer allows simplicity, as you have seen, as Paul was mentioning. The container database and PDBs become very central to that isolation you desire for your microservice. Transactional messaging and event store, again, are important in terms of exactly once messaging, of idempotency of your services, and the simplicity of writing these microservices. So you don't have to write a lot of error tracking code in these cases. And then Helidon, MP, and SE, the two versions, Paul talked about in terms of their programming models and how you would, either use these or, translate from some more heavyweight protocols out there. So GraalVM microservices are available. Again, there's a small, simple bit.ly link called Simplify Microservices. We'll cover some of that here so that you can get familiar with it. But you can run these on the Oracle Cloud. There's a free tier available on the Oracle Cloud. So if you click here, bit.ly Simplify Microservices, it'll take you in an area where you can run these labs on your own and get familiar with these, right? But in this workshop, we have some more time, so we'll cover some of these areas, right? So maybe there's some time for Q&A, but if you have any questions right now, please put them in the Q&A panel. I don't think I've seen any questions so far. If there are questions or at any point of what we have said, please put them in the Q&A panel there. So let's get started with the labs, right? So here is what this bit.ly Simplify Microservices would take you to, right? At this point, you can, in a free trial, you get 300 credits on the Oracle Cloud. This will take you to a free sign up on the Oracle Cloud if you're familiar with free signups on AWS or Azure, exactly, very similar to that. And then, this walks you through the setup and other things. And, we'll show you how it is done. And that takes you into the microservices aspect of lab, so that you can basically click on each one of them and it'll walk you through the steps. We can try to make it very easy for you to follow along, and then you can always come back on the Slack channel that we'll put on chat if you wanted to reach back to us, or write to any of us for help as you go forward. So I'm going to stop sharing. Maybe Paul, you can start sharing and cover in the lab.
Yep. Okay. Hello, my name is Paul Parkinson, and I'm going to walk you through the workshop on developing Helidon platform microservices using the Oracle Converged database, the ATP database, deployed on the OCI infrastructure. And so throughout this lab, you will be building up the infrastructure and microservices that are shown in this diagram here. And so by the end, there are a couple here, such as streaming and spatial and monitoring, that are being added to the workshop currently. So they're not in what I will go over, but all of the rest of this architecture here, you will be able to set up easily with this workshop. So having said that, there is a lot of content in this workshop. And so to keep this instructional video under 2 hours, you will need to pause the video at times and conduct your work and then resume the video to continue. So this is the URL of the workshop. And the nice thing about this workshop is that you can come back to this environment that you're setting up in OCI and finish the workshop later if you like, or add on to the workshop to design whatever microservices or things you want to experiment with. And so it's nice, you can go to this URL, like I say, and pick up where you left off. So these are the different labs included in the workshop. And as I say, there's quite a bit of content. So it's unlikely that you will get past lab 4 in a 2-hour time frame. But you will have a lot accomplished within 2 hours. And so very quickly in lab 1, you will set up some basic OCI resources, the OKE, the Oracle Kubernetes cluster. You will set up 2 ATP database instances, and you will learn how to use the Cloud Shell. Another nice aspect of this workshop is the whole thing can be conducted within the Cloud Shell, within the browser. So the only thing you need to do this workshop is a browser, and yet you're achieving this full architecture shown here. Lab 2, you'll go ahead and very simply grab the source code from the microservices and deploy a simple front-end microservice, just to have one microservice deployed. So you'll have this front-end, simulating a mobile app deployed by the end of lab 2. After lab 3, you will have set up database connections, tables, and AQ messaging. So you will then have connectivity between your Kubernetes cluster here, shown in blue, and your databases shown in red. And we have a database, a PDB, for different services to follow the microservice model of decoupling in that way. And then you'll set up the propagation between the queues that's used for the messaging aspect of the workshop. Then after lab 3, you've set up basically all of the infrastructure on here as far as OCI, object storage, and things like that. And so, you know, that will take you maybe half of the time of the workshop, half of the 2 hours. So within an hour or so, and you know, everyone will go at a different pace there, depending. You'll have the setup, and then Lab 4 will take you into a lot of the concepts, and you'll actually deploy this this full microservice app, and you'll be able to go through the concepts. And what that's going to look like, as far as the app itself, is this page here. So after that, Lab 2, you'll have this basic static front end. It won't do anything, but you'll be able to bring this up via the load balancer. And you'll be able to test connectivity from this microservice that's deployed in Kubernetes, test the database access from that to the ATP instances that you create. You'll then go, you know, you'll set up your messaging, which is just a matter of pushing these buttons. And then the actual app is, you know, you'll be able to start getting into that. And so this is what you see here as far as the application. You see different data types used, JSON for the orders, relational for the inventory. You'll see AQ, transactional event-driven communication. So you will see that you can conduct work and send a message within the same local transaction. And that makes for exactly once delivery and guaranteed atomicity. You will see a basic Saga, which is a data integrity pattern for multiple microservices, where all microservices use local transactions. There's no distributed transaction protocol, so that you can gain the advantages of microservices as far as scaling and things like that. And that's between the order and inventory service. We'll see event sourcing, which again is conducting work and sending a message describing that work. And you will see CQRS, which is command query responsibility separation, segregation, meaning we will insert orders. Which is a command using JDBC. But when we actually query for the details of the order, we will be doing that based upon events. And so there's a separation of the command and query APIs, and thus the name. And so you get the idea. It's a basic online store called GrubDash, fictitious store, and you will be issuing orders and things like that. And then we'll also show off some concepts as far as how easy it is in Helidon to integrate with OCI and Kubernetes and the database in general. But it'll show some certain concepts as far as showing metrics, showing health and liveliness probes of Kubernetes working together with Helidon, so that you have reliability as far as automatic pod restarts and things like that, and tracing as well. And so that's what we'll have done. As I say, I will go up until Lab 4 in video, but I encourage you to continue on to do the other labs. Lab 5 is actually quite straightforward. What you will be doing is simply undeploying the original inventory service that you've deployed, which is a Helidon MP implementation, and then replacing that or swapping it with an implementation of the inventory service in a different language, such as Python. We also have JavaScript and Helidon SE. And so that's a quite simple lab to go through. And then the Lab 6 is about scaling. We will put stress on the application such that it will demonstrate horizontal pod scaling in the Kubernetes layer, as well as scaling in the database layer. And then we have an Apex lab as far as Lab 7. And I want to mention that we are continuously adding to this workshop. So any feedback in general that you have, anything you want to see added or things like that, please, feel free to contact us. We will definitely get back to you. And we have incorporated different aspects into this lab and are working on different aspects now based on customer feedback. So please do let us know. I believe there's even a note here as far as if you see issues, you can go ahead and submit this form and the workshop name, lab, steps, things like that. So even, you know, issues or just, as I say, any kind of feedback, we'd be interested in that. And that link is right here in the workshop. So this is the URL to get to everything you need. And so let's hop in. We are going to first go ahead and sign up for an OCI account. So for this workshop, if you have an OCI account already, that's great. If not, you can go ahead and sign up for a free trial. And that will give you all of these resources are always free. That is with the exception of OKE and OCIR, which you will get, I forget the dollar amount, but you'll get a certain amount of credits for up to 30 days. And so you can go ahead and use that. If you have a free trial already where you used all the credits or something like that, this workshop up to Lab 4 costs something like $2 actually, if you want to, you know, just continue. Then it only, you know, costs a couple dollars to run. If you're going to start doing things with scaling and load and things like that, it may cost more, but just so you know the different options. So go ahead and sign up for a free trial. I'm going to kind of make this a split screen for this workshop. I think that might be the easiest rather than jumping back and forth. I'm going to have on the left the documentation, and on the right the OCI console and the Cloud Shell that we're going to use to conduct the workshop. So just creating an account. And so once you've done that, that's a fairly quick process, probably take less than 5 minutes. As it says, just enter email, country that your region, things like that. And then go ahead and sign into your account. It will sign you in automatically after you do it, and you will be on a page such as this. And this is your OCI console page. So now we're all set with that. Again, you can click over here and to see where you are in the lab, look at the different labs in the workshop rather. So now that we've set up our account, let's go ahead and set up this infrastructure. And what we will do here is go ahead and launch the Cloud Shell. Let's start that first. So that's this icon up here in the OCI console. We'll just go ahead and click on that. And this is the first time using it, so it'll take a few minutes to initialize it. And while it's doing that, let's just take a little overview of all the things we're going to install here. So we're going to get the workshop source code, first of all. We're going to create a compartment in OCI and then go ahead and create the Kubernetes cluster, the 2 ATP databases, the OCI registry for our Docker images, and the auth key for the login, and log into it from the Cloud Shell. We'll then go ahead and also access the Kubernetes cluster from the Cloud Shell. And then we'll install the GraalVM JDK, Jaeger that we'll look at for tracing later, and the front-end load balancer to actually access our microservices application. So we see the Cloud Shell is ready here. Let's proceed to step 2. We will go ahead and just curl the source. So we'll go ahead and copy that command, run that. And once that's done, we'll just go ahead and cd into that directory. We'll move on to step 3, which is to create the OCI compartment and the OK cluster in that. So we'll go to this menu here, down to identity and compartments. We will then click create compartment. And you can really name this whatever you want. We're going to name it MS Data Workshop. And we can give whatever description we want here. And then just click Create Compartment. We'll go ahead and go into that compartment and go ahead and copy. I think maybe we could have done that from the last screen as well, but go ahead and copy the OCID for that compartment we just created. Now we'll go back to this Cloud Shell and we can verify we're in the correct directory in case the Cloud Shell session will time out after something like 20 minutes. And so when the Cloud Shell will preserve all of your files, but you will come in with a new session. So if you have timed out, you know, that's why that instruction is there to verify you're in the workshop directory. And indeed we are. Then we're going to go ahead and run the command to set the compartment ID. So we'll go ahead and set compartment ID. We see that's in the directory, and then paste in that compartment OCID that we just had from up here. And then we're going to add also the region ID. And so you can determine the region ID. One of the easiest ways is it's actually in the Cloud Shell. So it's right here. I'm using US Phoenix 1. You can go ahead and copy that. It's available in the console a number of places, but that's convenient. So we have the arguments, set compartment ID, the compartment OCID, and the region ID. Just go ahead and hit enter. And that's all. We've just stored the values. So now to create the OKE cluster, we'll go back into the OCI console here. And we're going to go down to Developer Services this time and Kubernetes Clusters. Make sure you are in the newly created compartment. So over here is the compartment list. And here is our compartment. I named my tenancy MS Data Workshop as well, misspelled, but just to point that out, that's the tenancy and this is my compartment underneath. So, and then we'll go ahead and hit Create Cluster. And we'll choose to do a quick create and launch the workflow. And we'll go ahead and just name this MS Data Workshop Cluster. And hit next. And then we'll go ahead and create cluster. So you can see it's extremely easy to create a Kubernetes cluster, and you can see all the resources underneath being created for you. It's, you know, you didn't need to do anything for this. We'll go ahead and close that. And this takes a variable amount, but it's generally definitely done within 5 to 10 minutes. So while we're waiting for that to provision, we won't waste time waiting. We'll go ahead and create databases at the same time. So all we have to do is go ahead and go into our Cloud Shell here and issue this command to create the ATP databases. Go ahead and hit enter. And at any time, of course, you can maximize the Cloud Shell here. So we can go ahead and maximize the Cloud Shell to get more real estate on our screen. And so just by running that script, we've now created 2 ATP data sources, the order DB and inventory DB data source. And we can confirm that this matches that output. So that, just like the OKE cluster, that's now provisioning behind the scenes. And we can proceed to create an OCI registry and auth key and log into it from the Cloud Shell. So now let's go back here and we'll go to Developer Services, Container Registry this time. Developer Services, Container Registry. Let's go ahead and minimize our Cloud Shell so we can see that. And take note of the namespace. So here we see this namespace. We'll have this type of value, and hit create repository. And then you can really put in anything here. So we're going to put in first name, last name, and MS Data Workshop. And we're going to go ahead and make this public just for convenience. We can set up keys to set it to be private, but for convenience, we're just going to make this public and hit create. And now we can see that has been created, okay? And then we're going to go into our Cloud Shell and run add OCIR info. Go down here and run that. And we're going to provide the namespace against this value here. And as the second argument, the repo name. And we gave that the name, I gave it my name / MS Data Workshop. And all of these script commands were saving the values into file. And so they're nice and preserved. They're saved into this working directory, as you can see here. And so, it's nice we can preserve it. And we're going to use it later when we're building the microservices, etc. So now we'll go ahead and create auth tokens. And this will allow us to access the OCI repository to push our Docker images for our microservices and pull them, etc. So let's go ahead and click the settings and go to user settings. Hopefully you saw that, click the little icon there. And we're going to go down to auth tokens. And we're going to hit generate token. And we'll just call this MS Data Workshop token. Generate that token. And now this is very important because you will not see this token again. So let's go ahead and copy that. We'll just leave the screen open to be safe. And now we'll go into the Cloud Shell here and issue the Docker login command to log into OCIR. And we'll provide the username that you used to create the account, which is generally an email. And we'll provide that auth token that we just generated. And we need to make sure that you put the auth token in quotes. So quote, paste the name of the auth token, end quote. And we can see that login succeeded. Now let's go ahead and test it by doing a Docker images command. And we can see the repo is empty, but we can at least see, access for Docker images. Then let's go ahead and access OKE from the Cloud Shell. So we'll use this command verify OKE and create the kube config. That's the config necessary to access the Kubernetes cluster. So we'll just go ahead and paste that command in. And you can see it's creating the directory and writing the config to it. And then as a test, we create the MS Data Workshop namespace, Kubernetes namespace, and we see that that was created successfully. So we now know that we have created the Kubernetes cluster and we're accessing it successfully and issuing commands against it. So the last thing we'll do in this first lab is go ahead and install GraalVM, Jaeger, and the front-end load balancer. So we'll just copy that command, paste it into the console. And this will go ahead and do all those instructions for us. Now, while we're waiting for that, we can go ahead and move on to our second lab. So again, in our second lab, we're going to set the values for the workshop in the environment. We're going to build and push our first Docker images for the workshop. And then we're going to build and deploy and access that front-end UI microservice. So to set the values, we're simply going to run these commands to add and source properties in Bash. So we'll just wait until this install is complete as far as Graal and Jaeger. Okay, and then we'll go ahead and paste this command. Okay, as easy as that. And then we'll go ahead and source our Bash. And so again, this makes it convenient because whenever you open a shell, this will source all your properties. So again, if you want to leave and come back and start a new Cloud Shell session, all of your properties will be there. You won't have to source anything and build it up again. Also, it's convenient. Okay, so now let's try and run the build script in order to build all of these and push them to the repo, build all our microservices. Let's go ahead and run that. And as it says, there will be a lot of output here. As you can see, it's downloading and building everything. Now this will take a good 20 minutes to build and push all of these images since you're doing it for the first time. And in particular, the Python microservice takes a while to build and push. But again, this is building and pushing every single microservice in the workshop and doing it for the first time. So while you're waiting, in the background, if it's not provisioned already, ATP instances and the Kubernetes cluster will have been provisioned by now, as well as the load balancer. And during those 20 minutes, I'd encourage you to, just look through the console, for example, if you want to look at the databases that we created, you can go into this ATP area here and see those two that we created with the script. But in any case, you'll want to pause the video at this time and wait for that to happen and come back. But now that we have built them and deployed them, we'll proceed to the next step, which is to go ahead and check them in the console, check the containers that we just pushed. So we'll go again to Developer Services and to Container Registry. And we will see all of the microservices we just built and deployed. Okay. And so we're going to go ahead, as I said earlier, just as a convenience for making these public. You can, of course, make them private with keys, but we're going to make them, in the interest of time, just make them public. So we'll go through and select these resources, and under the actions, select these resources, and under the actions, change to public. Okay, we'll just do that for all of these. Okay. And now let's go ahead and build and deploy and then access this UI. So we'll go ahead and set the Jaeger address. We installed Jaeger earlier. script is going to go ahead and set the address of the endpoint, the load balancer that was created for Jaeger. So we'll just go ahead and issue that command. And we'll go ahead and source the bash file. So now we have that in our environment. Let's go ahead and change directories into our front end. So under our main workshop directory here, we have our different services, and so we're looking at front end. Go ahead and build and push that. So even though we had built and pushed the front end, we are doing it again here to incorporate the Jaeger address that we had just set. So we went ahead and build and pushed that. And now we're going to go ahead and deploy it. So we'll just copy this command to deploy. And we see our location. This, the fact that the load balancer exists is expected since we ran this previously, so that can be safely ignored. Now let's go ahead and check all the pods to verify our deployment. So we'll copy that command in. And we will see here that we have our Jaeger deployment for one thing, but our front end web service. And it's in the process of creating the container now. So we can just issue that command again. And we verify that it's now running. It doesn't take long for it to run. And there is a pods shortcut command. So there are a number of different commands. If at any time you're interested in a command list or various commands, you can type msdata workshop. And this will show you all your deployments, pods, secrets, services, and finally at the end, some shortcut commands that are included in the workshop. So by doing that, we've essentially done this command as well to get services, but I'll reissue that and we can see the services there. And so we can see that for our front end, we have this load balancer and it's running at this address. So we can now go ahead and open a tab and access our front end service. So we see that's the IP and the port is 8080. Let's go back to our tab here. Or actually, maybe we'll open, yeah, we'll open it here. And now we see our first microservice has been deployed onto the Kubernetes cluster. And so this is just static right now. So you can look at things, but these buttons won't actually work because they're hitting the database and things like that. So that's what we will cover in the next lab, setting up connectivity. So let's do that. We've completed lab 1 and lab 2. Let's move on to lab 3. Again, we'll be creating the Kubernetes secrets that will store the information for our microservices in Kubernetes to connect to the ATP databases. And then we're going to verify that connectivity and set up all of our messaging and tables and queues and things like that. So let's go back to our Cloud Console here. And we're going to paste in this command to go into the ATP secrets setup directory. And then we're simply going to issue this command to create all. And so this is doing a number of things. The output will show you this. It's bringing down the wallet for the two databases, which has all this connection information files. And then it's translating them or creating from them the Kubernetes secret. That Kubernetes secret will then be referenced in the microservices deployment file in order to set up the environment for the microservice. And so again, we'll look into that a bit more. But basically, you can set up the environment variables for your microservice by pulling that information from these secrets. So we've already done that, create all. Let's go ahead and issue that MS Data Workshop command again. And again, let's expand this console so we can see a bit more information. And so what we're really looking for here are these secrets. And so we see the general binding information, the information for connecting to our inventory and order database. And then we also see secrets for our credentials for the admin user for the inventory service and the inventory user, and likewise for the order admin and order user. So we have all our secrets created. If, you know, this is just a cleanup, we won't do a delete all, but if you need to clean up later, you can just issue that delete all command. Okay, let's go ahead and verify and understand this connectivity. So we're going to go ahead and look at this deployment YAML very quickly. We'll just cat the file. And what we see here is the volumes that are mounted for this deployment bring in the secrets that we just created, that we just looked at in that command. And from those, we can then set this, the environment variables for our container. So we have a container here, which is our admin service. And we're setting this environment as far as the user, the password, and the URL. And we're getting that from these secrets that we just created from the wallet that we downloaded with that script. And see, we're going to be replacing values as far as the PDV name and things like that. So it's very easy, you know, to get this information, to create a database and then get the information into your application. Then we can go ahead and look at the micro profile config properties file. So these microservices are built with Helidon MP, which is an implementation of the micro profile standard. And part of that standard is this micro profiles config properties file. So let's take a quick look at that. And what we see here is the setting of properties to access our database. And so you'll notice this is the same convention that was used to set our environment in the deployment descriptor. So we have this type, and then the name of the object, and then values to set on it. And so this properties file serves as basically a mapping. That environment will overwrite the values that are in this config properties file. And so we have the information to then inject a data source into the app. So again, the basic flow is to create a database. From that database wallet connection information, create a Kubernetes secret, reference that Kubernetes secret in our Kubernetes deployment for our microservice, and by referencing it, set up the environment, the environment properties or whatever you're going to use for your microservice. Set that up, and then our Helidon microprofile microservice is going to pick up that environment and inject a data source into our source, into our class. And so that's what you will see here. Oops. copy this again. Okay, and then we'll see at the top of this file here, we will see the two data sources injected. And so this is all we had to have in our microservice was this inject name, and you can see this is the name we had before. And now we have a reference to an ATP data source, a database for a data source in our microservices app. So it's very nice, very decoupled, portable. You know, you can move around from different databases and things like that, or move the database itself around. Very handy. Now let's go ahead and deploy this. So let's go into the correct directory and let's issue the deploy. So this is doing a number of things as well, as far as setting up propagation between our two databases. So we have message propagation between the two PDBs. And so this is giving us information as far as setting up a DB link and things like that. And this is just all done behind the scenes. You don't need to worry about it. Okay, so now, now the deploy was successful, let's go check the pods command to see if it's running. Okay, and the pod is initializing. This initialization, particularly for the first time, there are a number of things going on as far as, you know, as I say, bringing those secrets in and, you know, referencing all of this. So let's check on it again. And now we see it's running. It didn't take that long. We'll go ahead and go back to our, this is telling us where our front end is, but we still have that open. So we'll go back to our application. And no need to redeploy the front end, of course. That's part of microservices, is that you can deploy each service independently. So no need to redeploy the front end. And we'll click on this data sources tab, and then we'll click test data sources. And this is running against that, making a query against that admin microservice we just created. And so we see it's made a successful connection to the order in the inventory service. So as simple as that. We now have our Kubernetes talking to our ATP data source. And then this is just going into the setup for our tables, queues, message propagation, etc. So let's go ahead and click on the Setup Data and Messaging tab. And very simply, we're going to go ahead and click each of these buttons in the setup so we can do these in discrete tasks. So first thing we'll do is create the users. So we're creating our, and that was very quickly done, our order user and our inventory user in the database. We're going to create our inventory table. So that was created. We're going to create our database links. And this is doing a number of things as far as pulling down information from object storage to create the links and things like that, but that was done very quickly. Now, then we'll go ahead and set up the table queues and the propagation between the two databases. And so this is doing a number of things now and verifying the whole setup. And so this can take a while because we're sending messages, we're checking the messages are propagated in both directions, things like that. And so if you want to check on the status as it's running, we can go ahead and copy this command, this log pod admin command, go back to our Cloud Shell here and paste it. And then we can tail the log for this admin service and see what it's doing. And so as I mentioned, you can see It has set everything, it's verified the DB links and all of the, it's created all of the queues and everything like that. Now it's publishing a number of messages of different types and priorities and things like that, just making sure this setup is complete. And then it's just doing a, you know, like a sleep and then waiting to listen to the messages and things like that. So. Okay, so that took about 6 minutes. So if you want to pause the video here and wait for that to complete, and then we can continue from here. But everything you can kind of tell from the output that things were successful or not. And then this is just if you happen to have do any maintenance on your database or anything like that, you don't need to go through all of this again. You can just set up the tables and propagation. Again, that's all that's saying there. And with that, we are complete with lab 3. So now we have all of our infrastructure set up. You know, that was a good, you know, hour or so at least. But we have all of the infrastructure that we discussed on the open page here. Let's take a look at that diagram again. At this point, we now have, we didn't set up monitoring or streaming, but we have every bit of infrastructure on this lower level here, suppose OCIR, object storage, our databases, propagation between the two databases, our OKE cluster, our mobile app, and our our mobile app front end service and our admin service, and we've built and pushed all of these images. So we have a lot done, and we're all set up to move to lab 4 to really start to look at some of these microservice data-centric concepts. So let's do that. So we will go ahead and deploy the other services, and then we'll go through the various, you know, saga, et cetera, that I mentioned earlier as far as step 2, metrics, health, and tracing. So one thing this app will show is different aspects of the converged database. So a number of different data types, but we're really kind of showing 3 and actually particularly 2 in this. So we show the order is inserted in JSON format. Meanwhile, our inventory is a normal relational table that we issue JDBC SQL commands against, whereas the JSON we're using the Oracle SOTA API, so we're just manipulating a JSON document. And then for delivery information, which we've added on in a later lab, we're using spatial information to show that. So we're just giving that sort of basic ER diagram for that. So now that we know what we're setting out to do, let's go ahead and go into the order directory. And then we'll go ahead and deploy our order service. Okay, so the order deployment pod is created, and the service that will front that microservice. And let's go ahead and do the same thing for our inventory service. We'll go into that directory and deploy. Okay, and then we'll do the same for our supplier service. The supplier service is just manipulating inventory. Okay, and then let's see the status of the deployments and see if our pods are running by running the pods command. Okay, so we see the supplier and inventory are still initializing. Let's just check again. You can pass -W and it will continuously listen for any changes. So you don't have to keep issuing the pods command. Okay, so we see all of our deployments are running successfully. Let's go to step 2. We will verify the order and inventory service. So again, we can go ahead and just run this services command as we did before for the front end and Jaeger. And we'll see all of our different services. Now, you know, all of our different microservices have services that front them, Kubernetes services. All right, so now let's go back to our application. Everything is now fully enabled, so we can go into our transaction and start to test some scenarios here. And so let's go ahead and check the inventory for the sushi by clicking on Get Inventory. And we can see that the inventory for the sushi is now at 0. So let's try to place an order for the sushi by hitting Place Order. And we do this in 2 steps. We place the order and then we click Show Order so we can see the different stages. So the initial stage of Place Order is that the status is pending because we are pending the retrieval of the inventory by the inventory service to see if this order can actually be fulfilled. And so when we go to show order, because there was not enough inventory, remember the sushi inventory was at 0, we expect this order to actually fail. And that's what we see. It failed, inventory order does not exist. And so what we're seeing here again is a saga between the order service and the inventory service. And the compensating activity of this saga for the inventory service is to restore the inventory back to the original state. And for the order service is to set the state it too failed. And you know, as in the normal case, it would go to successful, of course. And so that's what we see here. And this is a basic choreography saga, meaning that that saga is negotiated or worked out between the 2 services, as opposed to an orchestrator like LRA or a business process, where a devoted process would coordinate that saga between the participants. Okay, so that's a pretty good spot to stop. You've seen all the work done, and now we're starting to show the different concepts. And so, and then the video does go into the scaling and polyglot topics as well. So I'll hand it to Sanjay, but I really appreciate you watching. And again, please check out the workshop on your own time and contact us with any questions or comments you may have. And thanks again.
Yeah, thank you for attending, and please reach out if you have any questions to both Paul and me. Thank you.
Thanks.